Hi all, my name is Omar and this is a short video tutorial about the OMIQ, the EasyPanel integration, allowing for two things. One, the QC or QA or validation of your different spectral signatures on any spectral cytometer, essentially comparing your data empirically or experimentally generated versus the reference that we have in EasyPanel, or the one that you have set or that your flow core manager has set as benchmark. We'll talk about that in a second. The second purpose is essentially to build optimized and relevant panel accounting for your autofluorescence spectral signature or signatures, which is critical and important, especially if you're working on tumors and co-cultures and so on. Again, we'll chat about that in a second, but these have been long awaited and highly requested features that we're very happy to release just today. So this is a data set, again, including a few single color controls that I've run on my spectral cytometer, in this case the Cytec Aurora as an example, and this is my unstained control. I have my workflow just right here in OMIQ. This is where everything starts. Again, there are like specific tutorials about all of these steps, but what is of interest for me here is to reach the unmixing matrix. Which I'm going to make. I've gated on PBMCs here as just an example. You'll need to configure one or multiple autofluorescences. Again, there are specific tutorials about that, so I'll skip this here. And then generate your unmixing matrix, which is just right here. Then you need to click on Validate with EasyPanel, which will open a new tab, this time in EasyPanel. With two different subtabs. The first one, like I said, allowing for the QA or QC of your different spectral cytometers, comparing the actual one, the experimental one that you just generated corresponding to your single color control, versus the expected one that we have in EasyPanel taken from vendors or OEMs. And again, it's really important for us to give you guys the flexibility as requested by different scientists to set your own benchmark spectral signatures. You don't have to rely on EasyPanels. EasyPanels is the one that is there by default, but if you believe you've run your single color controls on beads or cells or in whatever experimental context that makes sense for you, you can set that. So the way you do this is you'd set this here. I'll call this spectral signatures benchmark OMAR demo, for example. And this way, under this tab now, spectral signature benchmarks, this is a page that allows you to see all the different benchmarks. By the way, you can have one or multiple, and these can be shared. And this is how you can view them. You can see the benchmarks that you've defined or that your flow core manager has defined for you. And then here, you'd be able to set them. When you compare, again, by default, you'd have the EasyPanel, but again, you can compare versus your own so that in any subsequent single color controls, you can again compare them versus what you generated. And we try to quantify these, similarities using the similarity scores. It's sorted or ranked from lowest to highest, and again, you can decide to have a certain threshold. Say anything that is below 0.95 similarity is a fluorochrome that I'd be concerned about, or data that I'd question because maybe the fluorochrome hasn't been stored properly or is not in great condition. So this is one thing. Again, you can export the data as an Excel. You can share it with other users. The other use case is building panels accounting for your existing autofluorescence. You guys saw here that I've defined PBMCs and I've configured my autofluorescence channel. Over here, you can have multiple autofluorescences. This is how you'd move between them. And then you can design panels accounting for these. So this will automatically choose the cytometer that was selected and that was used to generate this data set, and then we'll put you right in the second page of EasyPanel. And then this is where you'd add the different markers. So I'll just add a random set of markers here, and then get your panel design, again incorporating or accounting for your autofluorescence. And again, this is really, really important to optimized panels, because you'd want to make sure the fluorochromes in your panel avoid where your autofluorescence is. And again, this is really critical for people working with tumors or co-cultures. So you see here, this is the autofluorescence of my PBMCs in this case, and the tool, make sure to minimize complexity, singularity, and do all the panel design criteria and optimization accounting for this autofluorescence which you observe here. Hope this helps, and as always, please let us know if you have any questions or comments.